So let's just turn this up. What's that? It's not that we care. This is actually pretty frivolous data. It's the fact that they advertise percentages and then they're wrong. So that's why I want to keep checking. I'm like, let's just keep checking to see if they're consistently wrong or not. Because it could just be a fluke that they're wrong, yeah? Here are the percentages. Here we go. Here are the percentages Mars tells me they should be. I'm going to turn this one on so I can actually see it from over on the side of the room. Here we go. Right here. They tell me this right here. They used to say this in their letterhead. They've changed it and now it's become this. So Mars tells me that you should have 14% yellow. The proportion of yellow should be 14%. The proportion of green should be 16. The proportion of brown and red should both be 13.
Yeah, that's off.
Well, good. So if you guys are already cracking the bags open and counting, that's good. But you got to remember, there's going to be sampling error within the bags. That's why I want you all to count them, and we're going to put them all in one big data set. So yes, I would imagine that we're going to be off significantly from bag to bag, right? Brown and red are both 13%.
Are they supposed to have the same number of M&Ms in each bag?
They sell them, according to them, they sell them by weight, which means I'm betting that there probably are a similar number. And I bet you know what's funny? I've never done the entire bag, but the way I've set the data collection up for this, you can sample distribute the number of each color, and they're bell curved, which is pretty slick. Which means the machines are probably working correctly. You're getting bell-shaped distributions in each. We'll see if it stacks up. It usually stacks up that way in class. So Frankie, a bunch of bell-curved numbers added together should be a bell-curved number. So I think yes. I think the answer is yes to your question. Blue should be 24. And what am I forgetting? Yellow, green, brown, red, blue, orange. Orange, I think that's a 20. Yeah, let's check to make sure this makes sense. Okay, let's make sure these numbers add up to 100%. 14 and 16 is 30. Whoops. 50. 26 and 24 is 50. Yeah, we're good. That's 100%. So that's what Mars tells me they should have. Now, if they tell me they should have that, I really have no reason not to believe it. They tell me that's what it is. I believe them. Up until the point that I don't. So why would I not believe them? Because of what Danielle just said, and because of what Frankie just said. Danielle just said, yep, that's not what my bag looks like. And then Frankie goes, the data might look off. This is how it starts. Mars gives you a distribution. So which hypothesis is this, friends? Which hypothesis is this? The one that Mars gave me. The one I have no reason to doubt. That's the null. Yeah, this is your H0. Can you see that we're still testing proportions? I mean, clearly there's 6 of them. We're testing proportions. The proportions themselves, the little p's, are just the proportions of each color. So that little bar that says define the variable in terms of what you're testing, just you're testing the proportion of green, proportion of yellow, blah, blah, blah. That's the null hypothesis. Mars told me that. I have no reason to think otherwise about it. Exactly right.
So brown and red are the same.
That's what they say. Yes, red and brown should both be 13. Yellow, green, 14, 16, 24, 20. Please, Cassidy.
I'm just eating a bag of Skittles. I'm wondering.
20% each. 5 colors, right?
Yeah.
5 colors. They say they're 20% each. I've always been partial to M&Ms. The more chocolate versus just the sugar blast. And plus, it's 20% each. The real reason, Cassidy, honestly, is because that's the iPod randomizer on 5 songs. Which is it's too much like the iPod question. M&M's at least makes it different than the iPod. Does that make sense? I apologize. Yes, Skittles and M&M's. That's a hell of a breakfast, sister. Some coffee in there. You got 3 basic food groups: sugar, milk chocolate, and caffeine. All right. So, what are we going to test? So Danielle said, it's not what it is in my bag. And Frankie said, the data's different. What's the research hypothesis we're going to test? Which one? Or ones? Emily, I love what you just said. So Emily just said, in words, that they're not equal. And then my question back is, which one? And then she goes, I don't know. That's right, exactly. There are 60, what's 2 to the 6th power? 64. There are 64 ways to look at all 6 of these and whether they're equal or not equal to their percentages that they're claimed. 64, 2 to the 6th. The reason why I say that is each one of these is like flipping a coin. Either the proportion of yellow is 14 or it's not. Either green is 16 or it's not. It's like flipping a coin 6 times. Either is or it isn't. Now I'm not saying it's equally weighted, but it is binomial. So there's 64 possible ways. One of them is this is 14, this is 16, this is 13, this is 13, this is 24, this is 20. That's one of the 64 arrangements. What's another one? Give me another one. Yellow is not, but the rest are. There's another one. Give me another one. Green is not, but the rest are. Give me another one. Orange is not, but the rest are. Give me another possible.
Green and yellow are.
Green and yellow are, and the rest aren't. How about green and yellow aren't, and the rest are? You see what we're doing here? How long is this going to take? A while. A while. So can we group all of that into one English statement? Not a mathematical one necessarily, but an English statement. I'll get you started. At least. At least what? At least one of the proportions is significantly different than it's claimed. That takes care of all of them, doesn't it? That takes care of 1 up to all of them being different. At least one proportion is significantly different than claimed.
I already have several.
Good! But again, you've got a very small sample size, which means low power.
Right.
But that's okay. We've got 20 times the sample size you have, Frankie, which means we can put it all together and make one large sample. Yay. Now, can anybody see a problem with that research hypothesis right now? It's okay if you can't. Can anybody see a problem with it right now?
It's too general.
It's too general.
And we don't know how many M&Ms they use to count.
Good. Oh, I don't think they do either.
Okay.
You'll see the form letter I've gotten back from them. If you've ever been by the office, you've seen this. When you walk into my office, off to the left of my office, I've got a series of letters I've written to Mars and a series of form letters I've gotten in response to them. And they don't know what the hell's going on over there. No offense, Mars, but you don't know what's going on. But anyway, more importantly is, so suppose, for example, we get a big p-value. We haven't done the study yet, but let's just suppose we get a big p-value, bigger than 5%. Who are we going to believe? Big p-value. Who are we going to believe? No, right? McKenna's saying no? Yeah, big p-values mean that there's no reason not to believe this. Well, I know exactly what that says. It says that yellow is 14% plus or minus, green is 16% plus or minus, and so forth and so on. What if I get a small p-value? Who do I believe? I believe this. What's the next question I have to ask then? At least one of the colors is off, right? What's the next logical question? Oh, good. Maybe you're not seeing it yet. I just heard it whispered back there. Which one? Or which ones? That's one thing the test is super general about. Let's not deal with that right now. Let's see how the test comes out first. Because remember, in the iPod randomizer on Tuesday, we got a big p-value, right? We got a big p-value, which means the randomizer appears to be working. Which means we didn't stop to think which song caused the issue, because there was no issue. But if you get a small p-value, then you have to go back and look and find out. And we'll deal with that if we need to deal with that at the end of the day, yes? At the end of the day, we'll deal with that. So everybody good with the hypotheses? Okay, can you handle the errors? Type 1, type 2? Maybe. Whoop, false. Okay, not. Type 1.
False positive.
False positive. No, I can't pick on Danielle. You're my error girl. I gotta pick on somebody else. No disrespect intended. Give me a type 1, false positive, contextually. I want to make sure we can verbalize this, if you want to verbalize it.
It means that the samples are equal to that, but they're not.
It's false positive. What does a positive test result mean? That we're saying something changed, which means we're saying this. We're saying the colors are wrong, when in fact,
They're not.
they're not. Yes. We're saying the color, or colors, at least one of the colors, is wrong, when in fact it's not. Yes. That's false positive. We'll talk more about that momentarily. False negative?
Saying that the colors aren't wrong, in fact they are.
Saying the colors are not wrong, when in fact they are. Anybody have a favorite to pick? Which one's worse? Which one you want to avoid more? Or do you not care? Because this is pretty frivolous. Yeah.
It depends on what your favorite is.
It depends. Well, that's true. This is pretty frivolous. You can feel free to leave number 5 blank if you want to, and we'll just give you a point for it. It makes more sense with the blood doping. It makes a lot more sense with the blood doping, the error analysis. We'll talk more about that. So there's your Gesundheit. So false positive says, ha, Mars, your colors are off. Oh crap, we screwed up. Right. False negative is everything's fine. But it's not, we just missed it. Got a negative. So now we know we have to use the chi-square distribution. That's the newest Google. Emmerdemmogram. We know we have to use chi-square because we have multiple proportions. We have 6 proportions. So now the question is, we got to do data collection. So here's what we're going to do. I'm going to turn the camera. Oh yeah, grab a bag for sure. I'm going to come around. I got the Excel spreadsheet set up to do 2 things: collect the data and also look at Frankie's questions. I'm going to turn the camera off momentarily while I collect the data and then turn it back on.